All right, a reaction with HCl and an alkene. So this is classic addition reactions, but we should look and see here. Let's number at least the carbons of the alkene, 1 and 2. So again, we look at these alkene and say, carbon 1 has 2 hydrogens bonded to it. We should go ahead and draw those in as well. Draw on this hydrogen, draw on the hydrogens on the alkenes. Make sure it's easier to see. We also can see here probably, right, so carbon 1 has no other carbons bonded to it. Carbon 2 has 1. So there's a difference in this alkene. One's monosubstituted, one's not substituted at all, any other carbon. So what we're going to do here in the first step, of course, is we're going to use the pi bond as a nucleophile, and it's go for the best electrophile, which would be the H plus from the HCl. So we'll break that HCl bond. But at this point, we have a choice. Where do we want to make the new CH bond? The new CH bond needs to go on carbon 1 or carbon 2? The CH bond. So the way to think about it, where would you rather have a carbocation? Carbon 1 or carbon 2? 2. So where's the CH bond going to go then? No, the CH bond's going to go on 1 because 2 is not going to get a bond, right? So that, right, be thinking, right? There's 2 things going on here. You're forming a carbocation, but you're also forming a new sigma bond, right? 2 electrons, a new sigma bond between carbon 1 and this H. So don't forget about that too. Okay, so we're going to make a carbocation. And we made a new sigma bond, CH bond. This H is still there. Number of my carbons, carbon 1, carbon 2. So what new bond do we form? A new sigma CH bond. Let's not forget that. This CH bond is still there. Nothing changed. Have a carbocation. What kind of carbocation is this? It's a secondary carbocation. Very good. Is that the best carbocation we can make? No, so we should be thinking about rearrangements. And what do we think about when we think about rearrangements? We look for those hyperconjugation buddies, right? Those sigma bonds. How many bonds away? 2 bonds away. 1, 2, right? 1, 2, 1, 2, 1, 2, 1, 2. And then what else is here on this carbon that's not drawn in? There's a hydrogen there. That could be important. If I move that hydrogen, if I rearrange, I can make a new plus charge on that carbon, which would make a tertiary carbocation, which of course is more stable, so that's possible. And that's what I'm going to do. New H is there. Plus charge is here. Excellent. This was carbon 1, carbon 2. Of course, we forgot all the way through along for the ride was Cl minus, wasn't it? To balance our charge. Right? We start out with how much charge? No charge. So we make a carbocation, make a plus charge. We better have a minus charge there as well. Now our Cl minus is going to work. So what's it going to do? Carbocation's flat. The Cl minus is going to come in an SN1 type fashion. Now be careful here. What kind of products are we going to make? Let's take a look. We're not sure to start. Chlorine added there. What kind of, so that's do we make an asymmetric center? Do we make is there an sp3 hybridized atom with 4 different things bonded to it? Methyl, ethyl, nope, it's not. Be careful, right? This is not an asymmetric center. Do we need to say plus an enantiomer? No, as a matter of fact, if you said plus an enantiomer, that tells me you don't know what an asymmetric center is. So be careful, right? Always thinking plus an enantiomer. I see a carbocation plus an, nope, no, be careful. Wait to worry about that enantiomers, diastereomers stuff till you're the very, very end when you're done. Right? So there would be the product. Following rearrangement. So that's the one of the things you got to be careful when you do HCl, HBr, HI. Those make carbocations, H2SO4. If you make carbocations, you can rearrange. Right? The new ones we learned, the mercury, the boron, the Br2, they don't make carbocations, so they don't rearrange.